Okay, so our first paper is risk assessment in IoT case study, collaborative robot system, presented by Salim, Chehida, researcher at the University of Grenoble in France.
Hi everybody. So my name is Salim Chehida from laboratory Verimag of University of Grenoble. In this work, I work in the specification, design, and verification of cyber physical systems, IoT systems. I also work on the security of these systems. So in this work, we propose an approach for risk assessment in IoT systems, and after that, we apply this approach to collaborative robot systems. First, I would like to thank all the authors participated in this work from Robotnik Automation Company and from Airbus Defense and Space. So I think you can share the video.
Hello everyone, this work is funded by BRAIN-IoT project that aims to develop framework for reducing the effort of developing, validating, operating and monitoring IoT-based systems. In this work, we propose an approach for risk assessment in IoT systems. Then we apply our approach to analyze risk in collaborative robot system. First, I would like to thank all the partners and authors participated in this work from Robotnik, Airbus, and Imaxa companies. This is the plan of our presentation. We first start by the state of the art of existing standards and methods for security risk assessment. Then we introduce our approach and we present our case study of robot system for supporting the movement of loads in a warehouse. In the third part of our presentation, we detail the main steps of our approach and their application to our case study. Finally, we give some conclusions and future work. An IoT system includes a lot of devices such as sensors, actuators, and other physical entities. These devices can be connected using several communication technologies such as RFID, Bluetooth, Wi-Fi, and LoRa. The large number of devices and communication protocols that can be used in IoT systems can increase the vulnerabilities and attacks that can exploit these vulnerabilities. In this work, we propose a risk assessment methodology to identify and mitigate the risks. We aim to build secure IoT systems that ensure security requirements. There are a lot of common standards from international organizations such as ISO, NIST, and E3A. These standards provide generic guidelines for the security of systems. There are also some standards proposed by ITU-T, ISO, and ITSI that deals with some specific issues related to IoT security. In this study, we consider these standards, especially the ISO 27002 that gives general guidance to ensure the main security objectives. There are also a lot of existing methods for security risk assessment. For example, ABS method from the National Cybersecurity Agency of France that allows risk assessment in information system. The CRAM method from the Central Computer and Telecommunications Agency in United Kingdom that allows the qualitative risk assessment. The ORA method that supports the NIST SP 830 standard. The Mehari method from French Information Security Club that support the ISO 27005. However, these methods are generic and not consider the complexity of IoT systems. In this work, we propose a new method adapted to IoT-based systems. In our approach, we start by identifying the assets of the system based on reference IoT domain model. In the second step, we specify threats on the assets based on a common threats database from Airbus method. In the third step, we rely on the ISO 27002 to derive the security objectives from the threats. Finally, we give security requirements that implement the defined security objectives. Our approach is iterative, so the security requirements can be revised after the refinement of system assets. Also, the results of each step should be checked with the customer and security expert. We apply our approach to a collaborative robot system from Robotnik automation company in Spain. In this system, a fleet of robots is deployed to support the movement of loads in a warehouse. Robots move items from unload area to storage area passing by an automatic door that separates the two zones. This system is managed automatically without the intervention of human operator. To properly identify all the assets of the system, we refer to IoT domain model proposed by Haller. The IoT domain model defines the main concept and their relationships in order to avoid any ambiguity. Here we present some important concepts. On the left thing is the combination of physical entity together with its digital representation called virtual entity. There are two types of virtual entity, passive digital artifacts that correspond to a digital representation of physical entity stored in database or similar form. The second type is active digital artifact that corresponds to any type of active code, software program, or embedded application. On the right, device is a hardware with computing and network capabilities. Device can be sensor that allows to monitor physical entity, actuator that allows to act on physical entity, or tag that allows to identify physical entity, and it can be read by sensors. The domain model also describes other concepts such as users and resources. Here examples of assets from our robot system. The system includes different types of devices such as sensor. Here example of 3 robot sensors. We have also example of actuators such as door PLC and other type of components. For the identification of threats associated with the defined assets, we refer to the Airbus threats database. In the Airbus database, threats are classified into 8 categories and they can be caused by 2 factors. Environment factors such as natural event or human factors such as unauthorized actions or comprise of functions. In this table, we show examples of threats associated with assets defined in the previous step. This table is completed with our partner from Robotnik automation company and then validated and approved with security experts. In the last step of our approach, we rely on the ISO 27002 generic list to specify security objectives needed to protect the system assets against the identified threats. Here in this table, we give some examples of security objectives and we map each security objective with the covered threats. The security objectives should cover all the identified threats. After the specification of security objectives, we define security requirements. In this table, each security objective leads to the implementation of one or more technical requirements. The requirements should be approved by security experts, then appropriate countermeasures can be deployed to ensure security requirements. In this work, we have presented security risk assessment method for IoT systems and applied this method for robotic service system. Among the advantages of our approach, it considers the IoT domain model to identify the system assets. It considers standards to specify security requirements. It is iterative and considers the evolution and change in the system. We have applied our approach to collaborative robot system and also for water management system. In the future work, we plan to apply our method to other systems. We also plan to support our approach by tools. Thank you.
Thank you. Thank you so much. Are some questions for Salim from the audience? I would like to ask you something, Salim. You said you mentioned that
there is a question, okay. Rosaria, a couple of questions.
Yes, yes, I saw a couple of questions, so I will let Konstantinos. Could you please unmute yourself and ask the question?
No, hello. It was not actually a question. I was just raising the hand for the next presentation. No question.
Okay. Okay. sorry for this. Okay. Thank you, Konstantinos.
No problem.
So we have Zakaria. Hi, Zakaria. You can unmute yourself.
Hello. Yeah. Thanks. Hi, Salim. Thank you so much for the presentation. It's interesting. Actually, I have one question. At the beginning, you presented some state of the art and some standardization work or standardization work. My question: you have selected one of those standards. Did you use some criteria or some kind of like why you use ISO exactly and not other standards for risk management or risk assignment? Sorry. It was like just a choice, or like there is some specific requirements, or?
Yes. So yes. Thank you for the question. So in this work we have do the state of the art of all the existing standards about the security, generic security of systems, and also for the security of IoT systems. So here we with the help of some security experts in IoT systems, we have extracted the relevant and the adapted standards for the security of IoT systems. So for each standard, we have extracted some relevant part which is adapted to IoT systems.
Okay, thank you. Just another question, not like a really question about the presentation. This study you did with the other experts, it's included in the paper?
Yes.
Okay, thank you.
We have experts from in security from Airbus, Defense and Space.
Okay,
laboratory,
thank you.
And we have other experts, which is we help us for this work.
No, sorry, my question was more about the studies included on the paper.
Yes.
So yeah, okay, thank you so much. Thanks.
Okay.